Welcome to this module on data sharing as part of the AiMTT program. In this module, we're going to look at the following learning objectives. We're going to explore how a common operational picture can add value to an event or other crowd management scenario. And we will understand how legal constraints are an important part of sharing data and something we must take into account. What we will show you is how the way you can define your use cases with user stories can help you to make data sharing compliant. And we will assess how a shared data solution can be a part of your strategy to share data. First, let's start with the common operational picture. The concept of a common operational picture is about people from different organizations working together. For example, the event organizer, a municipality, suppliers, safety organization, and medical professionals. And the common operational picture then refers to the concept that these people are using and looking at the same information about the actual situation and/or forecasts, simulations, or other forms of analysis to work together to create a meaningful event or a safe crowd management experience for everyone involved. Having access to the same information supports joint decision-making. It involves better communication based on facts, and it allows for scenario planning or what-if scenarios. When it comes to sharing data, it makes a lot of difference whether you're sharing data real-time, like actual information, live feeds, or you're working with historical data, for example, from previous events. And historical data, since it's more static, can be shared or collected previously and then distributed in a way that is less technology intensive. You can simply have batch files or other forms of data transfers that will occur at some point in the preparations of the event, but that do not require a live setup to monitor the event. If you do have real-time monitoring, the benefit of that is that data will feed directly into your assessment of the current situation, and that will allow for more dynamic monitoring or even predictions. But it is also possible to use both types of data, where we have data that was collected previously to give us an idea of what to expect, and we have some live monitoring going on during the event itself. If you're sharing real-time data, you will require a technical solution to stream data. We will get to that in one of the later slides. When you're sharing data, there have to be agreements on which data to share, what somebody can do with the data, and other things that have to do with the ownership aspect of who controls and monitors the data. That is called data governance. The data owner is usually in control of the data, but when they share the data with others, they have to outline for which purpose the data is shared and how, for example, the municipality can use information distributed by the event organizer or vice versa. What you can do with the data can be limited to how long can you store it, can you modify the data, are you allowed to share it with others, but there are many more things you can decide on data sharing. For example, can there be commercial applications of the data? All these things can be discussed up front and formalized. Making those agreements is data governance. Also very important is data management, and if it's managed correctly, data can be very valuable to provide information, and information can be the starting point of actions to make better decisions. But data in itself is only valuable if it has a certain quality, and it is clear what the data means. Data definitions, the meaning of data, and from which source was it collected, from which time period is the data. It's all very relevant. It provides context to the data. If you describe this, that's called metadata. Metadata is data about data. It tells you something about how to use data. And what the data means. Coupling data with a description in the form of metadata is a large part of making data usable for other organizations. There are open standards, for example, the DACAT standard for metadata. These will give you a schema on which to base your metadata descriptions. If you use that, it will become easier for others to understand what the data represents. If you have multiple data sets or services or are working together with a lot of organizations who each have their own data sets and services that they're willing to provide, it can be very useful to compile a data catalog. And a data catalog is basically an inventory of the data sets that are available, and it lists the conditions on which you can gain access to these data sets. If this is done in a way with APIs, then it becomes easier for engineers and developers from multiple organizations to automatically access data and incorporate those data streams into their own solutions. API endpoints are a way of having machine-to-machine interaction with data. There is a request, which is followed by a response, and then the user will have access to the data based on the request he has sent. Some APIs require credentials, other APIs are freely available. Some examples of APIs that can be useful for crowd management are the Google Maps API, providing directions for multiple modes of transport, and the Open Weather API, giving weather information, which can of course be very relevant for an event. Using open standards for APIs will again make it easier for others to use your data, because they will know what to expect and how to leverage those APIs. Also, API documentation, for example with Swagger, is very useful to have somebody else use your data without requiring a lot of time from your organization to onboard them. Well, it's not just what we want to share, it's also what the EU regulations say about data sharing. And especially when it comes to personal information, there are laws to comply with. These limit the amount of data sharing between organizations that is possible without doing some extra work. The extra work means that you have the personal information sharing in a way that is fit with the purpose for which the data was originally collected. It lines up the way you're going to use it now. This is in accordance also with the people who have originally supplied you with those information. It's based on the same grounds, or something that you ask permission for upfront. And if so, the way you're sharing it with other organizations is also documented, is transparent. It has multiple things that are important, the regulations. But one of the most important things to remember is that always data sharing requires a grounds, a way for you to couple what you are doing, a task or a legal objective that you have. For example, let's say you want to share data from an event with the police in order to make sure it is safe. Then it's based on the law for the police to maintain public order, and that's the basis for sharing and using the data. Vice versa, if the police would want to share criminal information with another organization, that would be very difficult, because that other organization does not have the legal basis to use that data in most cases. So that would be something that they could not do. This is very important to remember, because this will always be sort of like the backbone of data sharing agreements when it comes, especially when it comes to personal information, the grounds on which you're sharing this, and that this has to be in line with a clear objective for which you need the data. There's also the aspect of the ethical part of data, and especially this is also relevant when you're using machine learning or other forms of artificial intelligence analysis. It is very important to make sure and to make explicit that the goal in which you're collecting or analyzing this data is benign, is not meant to harm people, but it's for a greater good or a good cause that you're using this data, and you're not damaging the person you're using the data from, or the impact of that decision is not very negative for that person. That is something that you want to make sure. And this can sometimes create tension with crowd management. For example, what if we want to use CCTV to make sure that people who want to disturb a soccer match or something like that, that they are not allowed in the stadium? And at that point, yes, then you get attention. Using that CCTV, facial recognition, it is something that will have a negative effect for the person involved. But then the grounds again becomes very important. You're doing this for a greater good because there are a lot of people there present who do not want to be harassed or have the danger of having that person in the stadium. And you will have to show that it's a balance. And the way that you're approaching this, also all the facial recognition data that you would be gathering from people who have nothing to do with rebel rousing, and the way you're processing this data, the way that you're storing it, you would have to make very explicit that you're conscious in the way that you're invading privacy of all the other people here involved. And one of the most important things here would be to minimize the data you're using. So, for example, if you were having facial recognition that would simply collect the image, analyze it, and immediately delete the images, and only flag for the people that were identified as that you should potentially block from the stadium, and that would be like a flag or a signal, and all the other data would immediately be discarded. That, for example, would be very much more in line with EU regulations and would have a lot better chance of being actually allowed to use and to stand up to these regulations, because then you would show that you're holding the privacy aspect and the other values that you're protecting, like the public safety, that you're balancing them out, and that you're trying to accomplish your goal, but in a way that minimizes the invasion of privacy for other people, and that you're actually and consciously trying to design a solution which takes this into account and which tries to minimize this privacy invasion. And again, also very important, it can be CCTV images, but could also be phone identification, or a Wi-Fi address, or any other information that would be directly or indirectly tied to individual people. So it's always very important to think on how this data will be used and whether that use is ethical. So is it in the benefit of the person whose data is being processed? And could we do the same things we want to do with less information? Or could we limit the amount of information or the length of time that we're storing it? These are always very important questions to ask yourself. What can help in shaping these thoughts on how to do this and what we're trying to accomplish is to use a user story format. And a user story is a way of describing what you want to achieve, and it's always in the same format, and it always starts with as a, and then you have a certain role or actor. Somebody is doing something I have need of, and then there's a functional requirement and demand something they need. In this case, could be specific information. And then you have this so that I can, then comes a task, which makes it that, and then comes a benefit. So it's a standardized way of describing what you're doing, what you need to do it, and why that's important and why it's going to create value. And it forces you to think on, for whom am I collecting this data and this information, and what would they need to actually fulfill the benefit that they are trying to get. So let's say, with the example we just gave, as a crowd manager, I have a need of preventing certain individuals from entering a stadium, so that I can keep the general public safe, which makes it that everybody can enjoy the soccer match. That can be a user story that allows you to set up sort of like, what are we doing and why are we doing this, and you can work from that with acceptance criteria. You can then say, okay, but in order to block those people, what would I need, or how could I gain information, for example, from CCTV, and what would be the requirements for that? How long in advance should I know this, or how timely should I receive such a signal? So how much processing time is there to give me that signal? What do we do with false positive? Let's say I have some facial recognition, but sometimes it misses something. Is that acceptable? What do we do with that? And also the retention and the ethical aspects of this. These are all things that you can work into your story. And this is the point where you can also think on, is this, can we do this with less data, or can we do this in a way that I'm just getting a signal when I think that somebody on the blocked list is at the entrance gate, and is that signal sufficient for me to act on that? Can I do something with that? Like, we have this person, he's standing at gate C, hold him. That could be enough. And what do we do with all the other facial recognition information? We don't need to retain it. All the negatives can just be discarded instantly. Because why would we want to store all this information? Why would we want to do that? Because these are people that are not necessary for our user story. We don't want to keep their personal information. We have no need for that, and it does not serve our objective. So let's make the solution in a way that it's not necessary to store that information. And by doing that, you have like, or for example, if you were using live camera feeds, blurring or obscuring faces can also be a way of making CCTV information, if you store it, less sensitive. And a lot of good best practices come from on-device analytics. So what I mentioned earlier, that they're doing the AI modeling on the device, on the edge of your network. It's working from the device itself, and it's just transmitting a data feed which has an output, a result. This is, for example, this can also be for having a direction or a flow rate, a count, average mood for a crowd, where we have a CCTV, but it's used as a sensor. So we're just transmitting information that's no longer about individuals, but it's about an area, a crowd, and a density can also be something that you can basically calculate or on device, or analyze on the device itself, and from there transmit just the values. And at that point, you don't have to send the images, which makes it less sensitive information. It's not even personal information at that point anymore. So that means that you can share the output without having to comply with excessive or extensive regulations about personal information. This saves you a lot of legal work, but it's also allowing you to do what you want to do as a crowd manager. So you're basically using the regulations to take a step back and think on, okay, how can we achieve this? Okay, we solve it by just doing the analysis on the device, so we don't have to transmit the sensitive data. We're just transmitting the data I actually want about flow rate, or in the other example I gave, like, which person do I want to prevent from entering the stadium, not I don't know. I don't want to know. And I don't want to know everybody at the gate. I just want to know the people I'm blocking or want to block. And this also, again, with the grounds for motivating your data sharing, it makes it easier to explain to somebody else, why am I doing this in this way, and why is it necessary to share this data. And if you do that, then you have a legal basis and a framework for making your data sharing compliant. Also, very important from that point onwards, you share the data. Access management. Who at that point will be able to access the data? That can be people or systems that are involved in a specific role or task, but it can also be about thinking, do I want to share all data for the entire city? No, just for my area. This is also a form of access management and already limiting the data you're sharing or collecting. And you can also do that from a time perspective. Am I looking at CCTV 24/7 for every day? No, I'm doing this, for example, 2 hours in advance of my event, during the event, and directly after the event when people are going home and we want to see the crowds disperse. And in that time window, we're collecting, we're sharing, we're using this data, and the rest of the time we're not, because then it's no longer necessary to serve our purpose. A lot of these things and these things that you have worked out together can be formalized by compliance documentation, such as a non-disclosure agreement where people are signing to keep something confidential. Let's say you're working with different organizations and there are some safety aspects involved, and you could sign a non-disclosure agreement not to tell to tell people about this, and all the individual people involved can sign this. That's very good. And between organizations, you can have a data sharing agreement. And if you're dealing with personal information, you're usually also using a privacy impact assessment or a data protection impact assessment document to describe the way you're doing your data sharing. And this gives you a place to have those checks and balances and make sure that even if you're doing everything right, you're writing it down, making it transparent so that somebody else, like a compliance officer or an auditor, could verify that your data sharing is in line with the EU regulations. And by doing this, by writing this down up front, you will have a lot of the privacy by design aspects tackled. Where this is a very important principle that you just basically shows that even if something goes wrong later, you have like the benefit of the doubt in that you were thinking of this up front. It's not like this happened to you because you were careless. You tried to do it as well as possible, and even if something went wrong, that's still very bad, but it's not like you completely overlooked the data sharing or the privacy aspects altogether. So it's important to have this as a sort of like a routine. Always try to think on these aspects, try to do them as well as possible, and learn from doing this also for future events. You can probably reuse some of your templating or earlier versions of documentation and adapt those to new partners. Well, when it comes to data sharing, there are multiple ways in which to go about this. And one of the typical things that you see is that we have like the traditional approach. We have people from multiple organizations. We bring them together physically in one room, and they all bring their own devices. They have access to their own systems, and they just show things to each other or tell them what's relevant. And in this way, there's a human integration. The data is not shared as data, but the insights are shared between the people, and that also works to a certain degree, and it's relatively easy to organize. Downside, of course, of this is that analytics or prediction want to use data from multiple sources will not be able to do so. So that's a downside. But the upside is the practicality, the way that you can easily organize this by simply bringing people together in a room. Another approach is to make a choice to use all the same application or technical system for sharing and using your event information. And a downside of that can be that you have like a one-size-fits-none solution where everybody has to agree to use something that's available, but it's not the right fit for anyone in particular. So everybody ends up with something that's, well, could be useful, quite useful, but not really in line with their tasks or information needs. And at this point, the shared system might underperform. Or to set it up, you would in the formal data sharing agreements, you find it takes a lot of time, and then you say, was it worth it? That can be a problem. It does not need to be a problem. Depends on the execution and the quality of that, but that is something that you could run into. Of course, the upside is if you do it, you have that shared information position. You can make that common operational picture, and it's possible to generate data insights or forecasts or whatever you're doing from different data sources. And a third approach is to have to focus on a shared system for data distribution to make that something that you all use, but then leave the way you visualize your data or use it up to each individual organization, allowing you to incorporate that more with your own way of working. And one of the benefits here is that you have all the upside also from the previous scenario, but you have more ownership about your data as well, and you can tailor your visualizations to the needs of your own organization, so you don't have to comply with sort of like a generally agreed user interface. One of the downsides can be that it requires more technical expertise from multiple participating organizations, where in the other scenario, you could have like one organization doing this for everybody, and then you would all just simply be like a customer to that organization. But this requires a bit more hands-on technical knowledge from each participant involved. Well, what's the right approach? Well, that really depends, because these different options also have their own strengths and weaknesses, and it will depend largely also on time and budget to prepare. Advanced technical systems will take more time to prepare, take more budget. You're more likely to do that if you have something that's recurring as a cooperation, then it becomes more useful to deploy a technical system. If it's a one-time thing, you might just bring everybody together in a room and be done with it. These technical systems, the more organizations are sharing and the more often they're doing this, the more valuable such a network can become. Then you really have the advantage of leveraging these kinds of solutions. It also very much depends whether you're doing it in one system or in a shared data network with everybody's own system. Also depends on the degree of control that the organizations are willing to release over their data. If they want to keep it in their own control, a data distribution option is better. If they're fine with just giving their data to one central organization that will service everybody else, then that's also a possibility. And the amount of extra value you can get from combining data sources into analytical products like simulation forecasts, other forms of geographical information insights or business intelligence insights. The more analytics are being done, the more value you will have from actually sharing data streams as data with each other, as opposed to just bringing the people together in a room or working with other less technical solutions. And it's also very important when it comes to the way these different organizations are organizing their own work. If everybody is fine with having a generic view or there's some possibilities in the shared system to customize the views, then it will also be a better fit than if everybody just has different needs that cannot be met. Then you will automatically choose to work with your own systems, and then at that point, either you're going to converge in one room, or you're going to have that data distribution option, but then the one shared system will not work for you. Well, what happened for sale was that the choice was made for a data distribution solution that had to do with some of the information sources and the number of participants. That was there were a lot of people and also analytical partners involved, so a data distribution option was useful. And there was still one system being used to view these things, and to some degree of success, because different parties, I think, might have been better off bringing their own system in retrospect, because people were still looking at the same things, but that did make it more difficult for some of them to incorporate it in their own work process. But the data distribution option was successful. It allowed multiple organizations, at least 12 organizations, were sharing data through the digital solution, which was the Data Services Hub, the DSH platform provided by KPN. And this allowed also for real-time streaming and advanced analytics, such as AI models, being serviced and deployed. And it was also GDPR compliant. So this was really a big upside. And the way this was done allowed for several organizations, including the TU Delft and Analyze, and also uCrowd, to do more advanced analytics, where TU Delft and Analyze focused more on AI, and the uCrowd focused mostly on simulations. And we with that, we were able to create meaningful alerts and other forms of forecasting that were useful for preparation and monitoring during the event. Each organization worked from an own tenant, sort of like a node in a network, and that gave them full control over their data and whom to share it with. Also, an upside was the ability to store data. Shared data was stored in a storage, which could also be used for evaluation, learning, and training for future events, which was also done with some other events that were prior to sale, which were like test runs for the sale 2025. And this data was used to improve on analytical insights. The visualization was separated, was done by another system, and in this case that was Map Gallery, which was used mainly by the safety region. But it could also have been possible to link up multiple systems. For example, also another system from the municipality or from the police or other stakeholders that were involved. This is a diagram of the parties involved, and roughly there were at the bottom of the diagram we have parties offering data sources, and more at the top of the diagram we see those data services being transformed into alerts and other meaningful information products which were then serviced to different systems that were in use, mainly in the Map Gallery environment, but there were also other environments involved also for crisis management that could leverage the same information if need be. And yes, on the side we see the archiving function, where we have multiple events also from the sale days itself, but also from other events that were happening prior to sale, which were stored and which were used as feedback loops also to create better AI models. Well, brings us to some of the conclusions for this module. First being, events and other crowd management challenges benefit from having a common operational picture. Data sharing is necessary to create that common operational pictures, to all look at the same information, to have that same information position. Data sharing does have legal constraints to take into account, and it helps if you formulate your use case or your user stories in a way that makes it possible to share that data. And one of the important things we mentioned was data minimization and other aspects that will allow you to really balance those values to make sure that you're completing your objective without using too much information or being privacy invasive without a very explicit and solid grounds to do so. So document your decisions in data sharing agreements and other documentation. That will also make it more transparent the way you're approaching this, and this will benefit you also for future events. When it comes to actual data sharing, there are multiple solutions, some more technically integrated and some less so. They each have their own upsides, and they should be assessed for you to see what would be the best for your crowd management scenario. But generally speaking, actually integrating data will allow you to be more able to use AI and other forms of advanced analytics for supporting your crowd management. So if you have the time and the availability to bring that data actually together, either in one technical system or through a data distribution solution, it might well be worth it. But it's something that you should always balance with the time available, whether it's a recurring event or not, and of course the money involved in setting up and maintaining such a system. Well, that brings us to the conclusion of this module. Thank you for watching.